Have you ever wondered how to separate a mixture of two liquids? Say acetone in water, or oil in water. These can be separated by distillation, and by using separating funnel. In this video, we will be studying these techniques. Now let us learn about distillation first. Distillation is the selective boiling and subsequent condensation of a component in a liquid mixture. It's a separation technique that may be used either to boost the concentration of a certain component in a mixture or to extract almost pure components from the mixture. Distillation takes use of the differences in boiling points of the liquid mixture's components by driving one of them into a gaseous phase. Now, do you think that distillation is of only one type? The answer is no. There are different types of distillation which are as follows: simple distillation, fractional distillation, steam distillation, vacuum distillation, air-sensitive vacuum distillation, and lastly, short-path distillation. Let us learn the first one, which is nothing but a simple distillation. It entails heating a liquid mixture to its boiling point, and then condensing the vapors instantly. This approach is only useful for mixtures in which the boiling points of the liquids differ significantly, a minimum difference of 25 degrees Celsius. Let us understand the process stepwise by taking the example of acetone. Do you know where we use acetone? Yes, you are absolutely correct. It is used as a nail polish remover. So, without further delay, let us see the distillation of acetone. To start, take the acetone mixture in a distillation flask fitted with a thermometer. Now, observe carefully how the apparatus is arranged. As you can see here, the distillation flask is joined to a condenser, which helps in cooling the vapor, and then, for collecting the condensed vapor, a flask is kept at the end of the condenser. Now, to start the distillation process, heat the acetone mixture slowly, keeping a close watch on the thermometer. See the acetone vaporizing at its boiling point, and then condensing in the condenser. This acetone can now be collected from the condenser outlet. On the other hand, the water is left behind in the distillation flask. Do you know that distillation processes are also used industrially? Can you give me an example of a liquid that is concentrated by simple distillation industrially? The answer is rectified spirit. After that is fractional distillation, which is a technique for separating liquid mixtures with not much difference in their boiling points. Several vaporization condensation stages are involved, which take place in a fractionating column. In this, the liquid mixture is transformed into vapors when heated, which ascend into the fractionating column. The vapors are then cooled and condensed on the walls of the fractionating column. The heated vapors from the distillation flask now heat these condensed vapors, resulting in the formation of fresh vapors. These fresh vapors now travel through the condenser and are collected in the flask. Do you know where this method is used? Fractional distillation is used for petroleum refining. Before going to the next method, let me ask you a simple question. Do you know that most essential oils and perfumes acquire their aroma from popular fragrant flowers? Yes. The flowers have the ability to secrete sugary and fragrant exudates, which serve as raw materials to produce perfumes and various essential oils. Steam distillation is a usual method for extracting essential oils and herbal distillates from a variety of fragrant flowers and plants. These liquids are steam volatile, but insoluble in water. Thus, steam distillation is the perfect method for extraction. In this distillation, as you can see, an additional round bottom flask is connected to the flask, carrying the mixture. The steam is generated from this flask, which is then transported to the flask containing the mixture. This steam slightly heats up the mixture and evaporates the component. Finally, condensation of the resultant vapor yields the needed distillate, which is collected over the water layer in the flask. Usually, this distillation method is employed to separate heat-sensitive components in a mixture. In this method, a high heat transfer rate is achieved, without supplying more amount of heat directly to the mixture. Following steam distillation is vacuum distillation, which is for separating combinations of liquids with extremely high boiling points. Heating these chemicals at high temperatures is an ineffective technique. As a result, they are boiled under reduced pressure. This results in the boiling of the components at low temperatures. To carry out this process, the components are transferred to a distillation chamber which is kept under reduced pressure. And the distillation is carried out in the same way as that of simple distillation. By using this method, we can obtain high-purity samples of chemicals that are degraded at high temperatures. An example of the same is glycerin, which is commercially purified by this method. The next method, which we have to learn, is air-sensitive vacuum distillation, which is similar to vacuum distillation. The only difference between these two techniques is that this process is carried out in the presence of inert gas rather than air. Now we are on to the last distillation technique, which is the short-path distillation. It is used to purify a small amount of a volatile compound at high temperatures. This is done at lower pressures, and the distillate usually travels a short distance before being collected. Hence, the name, short path. The last separation technique is by using separating funnel. Before discussing that, let me ask you a simple question. Do you know what immiscible liquids are? Actually, immiscible liquids are a mixture of liquids that do not mix with each other and are present in the form of two separate layers, like oil in water. A separating funnel is the perfect method that can separate these two liquids easily. The method makes use of the concept that the particles in the mixture have different densities. The creation of two layers is observed when the liquids are poured into the funnel and kept undisturbed for some time. The heavier liquid falls to the bottom, while the lighter liquid rises to the surface. The flow of liquid through the valve can be regulated, and the two liquids can be separately collected in two flasks. So, in this video, we learned about different distillation techniques and separating funnel.